Hello, this is Group 16 for the Chem 262 Spring 2021 semester here at Purdue University in West Lafayette. This is our final group project, and today we will be discussing artificial flavoring. So, what is artificial flavoring? Artificial flavorings are chemical mixtures that mimic natural flavors. They are not always accurate, but depending on the chemicals used and the manufacturer that produces them, they could have a close taste or even smell to what the actual flavor is. In the chemical makeup, esters are primarily responsible for artificial flavors. One fact is 90% of grocery purchases in the US contain added flavors. A few examples of what some flavors are is that isoamyl acetate mimics banana flavor, vanillin and ethyl vanillin mimics a vanilla flavor, propyl hexanoate are used to create blackberry and pineapple flavors, and ethyl cinnamate mimics cinnamon flavor, both made and found naturally. So artificial flavors versus natural flavors, what's the difference? So, considering costs, artificial flavors are typically more cost effective and are safer since they are man made and tested for health and safety risks. The molecular structures are oftentimes very similar, if not the same. Food companies are not required to label all specific ingredients, which is why many labels have artificial flavoring as one of those main ingredients in artificial flavor. A typical process used in the manufacturing of artificial flavors is the synthesis of an alcohol with a carboxylic acid in the presence of an acid catalyst, also known as the Fischer esterification. There are a few ways to create artificial flavors, with this method just being one of many, especially in the production of artificial orange flavoring.
The flavor of natural oranges comes from about 250 chemicals, including around 100 volatile components like limonene, ethyl butanoate, octanol, decanol, hexanol, and S-linalool. Specifically, the flavor in sweet oranges is composed of 22% alcohols, 22% hydrocarbons, 20% esters, and 18% aldehydes. They are mixed with non-volatile compounds like sugars and acids to create the orange flavor. Synthetically, orange flavor is made through Fischer esterification to produce octyl acetate. In the synthesis of octyl acetate, acetic acid and octanol or octyl alcohol are combined and heated in the presence of a strong acid catalyst. The catalyst is usually sulfuric acid since it results in a higher yield. Although, since the use of sulfuric acid can produce secondary reaction products that cause corrosion and environmental pollution, the reaction can also be catalyzed using ion exchange resins, which are extremely acidic and contain sulfonic acid groups. They are more environmentally friendly, less toxic, easy to separate, and reusable, which is why they are sometimes preferred. Since Fischer esterification is an equilibrium reaction, Le Chatelier's principle can be applied so that the removal of water shifts the reaction to produce octyl acetate, which is the ester that's primarily responsible for artificial orange flavor. Another way to synthesize octyl acetate is through the direct reaction between acetic anhydride and octyl alcohol to produce octyl acetate and acetic acid, though this process is less commonly used.
One of the most globally used artificial flavors is vanilla. Almost 18,000 metric tons of vanilla flavor are produced annually. The main compound that gives vanilla its flavor is called vanillin, and was first extracted directly steeped from the vanilla bean. Due to this extreme demand, there is not enough vanillin produced from vanilla beans alone, so ways to synthesize vanillin or find substitutes have been extensively studied. One such natural vanilla substitute comes from a substance called castoreum. Castoreum is an anal secretion that beavers use to mark their territory. Beavers have this substance in a castor sac located between the pelvis and tail of the animal. When identifying which of the hundreds of compounds that match the vanilla flavor within castoreum is a compound called acetanazole. While acetanazole provided a shortcut for a vanilla substitute, there are not enough beavers to satisfy this demand. So main alternatives are synthesized vanillin or a similar compound, ethyl vanillin. When comparing acetanazole, vanillin, and ethyl vanillin, all compounds are similar in that they contain a central aromatic ring with a ketone functional group attached, as well as an ether group. Examining more closely, we can see that acetanazole has a ketone group, whereas vanillin and ethylvanillin have aldehyde groups, and that the ether is metapositioned in acetanazole instead of para to the ketone aldehyde in the vanillins. We also notice that an additional alcohol group is present in the vanillins that is absent in the acetanazole. Looking closer at the synthesis of vanillin, which again makes up the majority of vanilla taste, the first synthesis was to convert eugenol to vanillin using acidified potassium dichromate. Eugenol is an essential oil extracted naturally from cinnamon, nutmeg, clove oil, and basil. Vanillin was also synthesized from parts of lignin, which is a byproduct of the paper manufacturing process. After that, vanillin was then synthesized from guaiacol, which is also found naturally in oils from celery seeds, tobacco leaves, orange leaves, and lemon peels, along with glycoxylic acid, which is also a naturally occurring carboxylic acid. Interesting ways to synthesize vanillin are still occurring, as in 2006, Mayu Yamamoto extracted vanillin from cow poop. Roughly 85% of all vanillin produced today is from guaiacol and glycoxylic acid, with 14% coming from lignin, and the remaining trace amounts from naturally produced vanilla bean. Specifically, the guaiacol to vanillin synthesis introduces another pathway that we have studied in our first year of organic chem. First, when you combine guaiacol with glycoxylic acid, the glycoxylic acid undergoes electrophilic aromatic substitution para to the alcohol on the guaiacol. Then the vanillin mandelic acid is catalyzed while in the presence of oxygen to form 4-hydroxy-3-methoxyphenyl glycoxylic acid. Lastly, this compound then undergoes oxidative decarboxylation, in which it loses a CO2 molecule to become vanillin.
Ethylvanillin is another compound that mimics the taste of vanilla. Similar to vanillin, it is synthesized through an electrophilic aromatic substitution, but in this case we are using catechol instead of guaiacol. Ethylvanillin has a much stronger vanilla taste, so much less of it is required to produce the same exact vanilla taste using vanillin. This makes it a more cost-efficient manner. It is artificial and is only produced in labs and not found anywhere in nature. In the bottom left picture, you see the first step in the reaction. Similar to vanillin, it uses the same type of process as an electrophilic aromatic substitution, and we produce ethylvanillin mandelic acid. And then it goes through the same pathway that vanillin did until it ultimately reaches the final product in the bottom right-hand corner, which is ethylvanillin. Unlike vanillin, this has an ethyl group attached to the O, the oxygen, instead of a methyl group. It is very hard for us to determine the difference between natural and artificial flavors just by taste, because the chemicals are so similar or the same that we taste them the exact same way. So as an experiment, we decided to get plain non-flavored ice cream and make 2 flavored batches. One, an artificial flavoring that makes it taste like vanilla, and one with pure vanilla extract being our natural flavored one. Now here's our video.
Go.
All right, I'm doing the taste test of the vanilla flavors.
This is letter A. Now for rinse. All right, letter B. Which? So this is the artificial one.
Mm-hmm.
I think
this was letter B. This was letter A. So with
careful consideration from both tastes, I actually got them correct, but I honestly didn't have a clue.
I just
took a wild guess. They both tasted very similar and smelled the exact same too.
Upon comparing the items we tried, both flavorings are from the same brand. The first one is Watkins Vanilla Flavoring, which is about $2.49 at most retailers for 2 ounces. The ingredients are water, sugar, propylene glycol, alcohol, artificial flavors, and fruit juice, which gives it the color. As previously mentioned, artificial flavors as an ingredient is just an umbrella term. The other vanilla flavor is the Watkins Pure Vanilla Extract, which costs $7.49 at most retailers for only 1 ounce. From this comparison, natural flavors are typically more expensive, and consumers should be mindful of what they are buying. These are the various websites and articles used for this project. Thank you.